All right, hello. Good morning. I think everything's working. It's been, let's see, there we go. Yeah, it's been a long time. And the reason is I've been just waiting for this announcement. Let's see, code sandbox. So the thing is, like, I've been working at Code Sandbox for like the last over 4 years, and then we just couldn't find market fit. Even though the product was like had market fit, it just didn't have monetizable market fit. So Code Sandbox had like these sandboxes, which never, like when I started Code Sandbox, we tried to monetize sandboxes, just couldn't make it. People, even though the sandboxes at Code Sandbox was way more powerful than like the fiddly type of sandboxes, like JS Fiddle and the others, they didn't have enough value added to them to like defend taking that much money for them. So that didn't work. And then we pivoted to a cloud development environment with dev boxes, well, which eventually turned into dev boxes. But developers doesn't want to code in the cloud. They just don't. And it makes a lot of sense because it's, even though you can add unique features and make collaboration more accessible, there's still this friction of moving your non-latency interaction with your local environment versus adding some latency. Like it's like gaming, right? You don't want to turn, if you're used to playing at 60 frames per second, you don't want to turn down to 30 frames per second. You have to add so much value for that, which, yeah, we weren't able to monetize that, at least not sustainably. But then Together came along, like all this AI stuff came along, and we were actually already reflecting on, like, okay, we have this amazing VM infra. Like maybe, okay, so if human developers doesn't want to use it, maybe AI developers wants to use it. And this was like early days where there was a lot of skepticism around what these LLMs can do. But they've proven to be useful. Like they're not like this hyped developer replacement, but they do have purpose. And one thing is using AI and LLMs in your local IDE as like an assistant to you're driving the process, right? And you have this LLM next to you that can help you out at certain points. But then you have this idea of like autonomous agents, which is a completely different ball game. This is like when you hook LLMs into triggers so that they can autonomously do something. So an example of that would be if someone creates a bug report on your repo, or someone creates a linear ticket on your project, that can trigger an agent, so-called agent, to go and prepare, for example, a branch, and maybe it even has a suggestion on the implementation. But at least it has done something on its own that prepares you to finish the job much more efficiently than what you would have done if you were to go into that from scratch. And the same with the bug report, like there's a bug report, and the agent just immediately when the bug report is created goes in, creates a branch, tries to fix the bug, and even if it doesn't fix it, it can tell you that it wasn't able to fix it and explain what it tried to do, and so on and so on. So it just makes you way more efficient. And this is the kind of stuff that you can do with our infra. You can run these agents either on the dev boxes themselves, or you can use the dev boxes as like this isolated coding environment. This has the potential to create a lot of different awesome solutions, and we're not alone in this. There are other companies that are fully investing into this, but we have we've been doing this for years, right? We just didn't do it for AI, we did it for developers, but it just turned out that AI is a much more suited user for it. Anyways, so Together, if you don't know Together, they are a company that also does infra, and they do infra for running LLMs, generative models, and they run open source models. So it's kind of like, if you think about OpenAI as like this locked-in black box, everything's about their product. Together is like a platform that any company can use to create their own like AI experiences and products on top of that, using open source models. And they can train them and to fine tune them, and then they'll get access to tools like Code Sandbox SDK, which might change into be branded more as a Together product as we move on. We'll see, but the point is that it's about giving tooling to companies so they can build products. So that's what's exciting for us. Is like, okay, if we as a company weren't able to create a product valuable enough to take money for it, maybe someone else, maybe we can rather give them tooling, because that's what we're good at, developer tooling, and then other developers in other companies can build products that they actually can monetize from. And then we are implicitly monetizing through our infra. Building products is hard. It's really, really hard. And building successful products is even harder. But anyways, this acquisition made a lot of sense, and we were able to continue our journey as a team, which is awesome. That was my big fear, is like we would kind of go down as Code Sandbox and we wouldn't be able to work together again. I will be super sad. But we were able to do that. And let's see, I'm just gonna, how do I make that thing? Yeah, whatever. Oh, it's here. Yeah. But we're a little bit split, like we joined together and we're working a bit split in the organization, helping out where we can, but we're also working on this SDK. So it's going to be exciting to see where things brings us. But like through this, I'm always like experimenting with how I work, and I always have these ideas, and I've been working with a couple of colleagues I haven't worked that much with at Code Sandbox, and they have this rebase flow. So they explore the implementation, and then they use interactive rebase using Git commands in the terminal to kind of create a good history for what they actually like figure out at the end, to tell like a good story in the PR. And it's very like Git rebase is very inaccessible. Like just the command that your commits are reversed when you look at them. You don't have access to the specific changes. It's only like it's from the perspective of commits. It's not from the perspective of like files or hunks. Hunks are changes within files. So it's very difficult to. It's inaccessible. So I was playing around with, like I've done this before. I built this npm package. You could like run this HTTP server, which had a UI that you could kind of like run from the root of your project, and you could move stuff around. But then I thought maybe a better way to do this is the VSCode extension. And I played around with an initial idea, and then I demoed this. Let's see. I demoed this update because the most important thing is like there's this huge spectrum of PRs, right? You might make small changes, or you might have these like big ass very like insane amount of changes. And like, how do you find a UX that kind of allows you to deal with things at the high level when you need to do that, but also allow you to deal with things at the low level if you want to do that. So in this extension, we can see like the original commits, and then we have these rebase changes. And when I click, this is just a prototype. So when you start the rebase, you get the same commits up here, but now it's more also from the perspective of the files. So here we can see I have made some changes to package.json. It shows the hunks. And then I've also made some changes to package.json here. And what I'm able to do is like, okay, no, I want these changes to be in the block commit. So I can just move them down there. And now everything is down here in this package.json. And my other commit is now like empty, which is indicated here, and I can remove it. But I can also go in and like some new commit, just add another commit, and then, no, I want them to be here instead. And no, this readme, I actually don't want that. I can put that in the trash, so that's not part of the thing. But then I can move it out of the trash again. So I can like play around with this as much as I want. And when I click it, it actually shows the rebase changes. So as you're rebasing, you can actually look at your files and see how these changes actually looks like. So the proof of concept has proven that yes, this is a really great UX, but there's a lot of complicated parts to doing this. And what I've been struggling with is finding like a good data structure to manipulate this, because as I said, we kind of think about PRs as commits, but going through this and playing around with it, I don't think that's the best perspective for rebase. You're not rebasing commits, you're rebasing changes to files. That's how I like to think about it. So let's see, maybe I can let's see, can I make it dark? Preferences, where are you? There should be like a dark thing here. Where are you? Preferences, always snap, dynamic. Oh, theme, system, cool. By the way, I'm kind of trying my setup here. I have my light up there, and my microphone here. The microphone is a little bit close to, well, we'll see. The way I would like to think about this is like, you have commit 1, you have commit 2. Well, this is the thing, right? You have commit 1, and then you made another commit. So you want this to be chronologically, right? This is how you think about it. So when you click your source control, you see your commits chronologically. Like the last one is the first one, or the oldest one. This is how we think about commits. Well, that's the question. Is that how we think about commits? Because when you go to GitHub, it's the opposite again, right? Yeah, it's very interesting. So I don't think we really reflect on this, but it's very confusing. But I think we should, like, this is a VSCode extension, so let's keep it to like VSCode so that it has a similarity with the Git extension. So we're gonna make it like this, but in terms of a data structure, you would probably do something like, well, it would be an array, and you would have like message would be commit 3, right? Commit 3. You would have a hash. And that's kind of like how you would think of a data structure for the commits. But this, when you think about moving, so let's make this, let's play with this. So message commit to hash, whatever. Did did I write the exact same thing? No. And then let's, can you see this? I can make it bigger. Let's see. Let's zoom in. So this is commit 3, right? It has a different hash. So what we're gonna play with is this data structure, basically. So this makes a lot of sense. And then we can say, well, within here, the following files were affected. And changes to files could be like a record, so that each key was like package.json. And then you could have like an array of changes there, like the hunks maybe. But this is like, the thing about this is that when you rebase, you kind of want the commits to disappear. That's the thing about interactive rebase from my opinion, is that it's about, it forces you into a mental state of commits, but that's not really how you tell the story of the changes. The changes aren't commits, the changes are in the files. So you just have these files and these changes, and you want to order them. You want to order the changes to the files and the changes within the files. And then you want to create like grouping of these changes, which are kind of like chapters in your story. So I was messing around with this data structure where you wouldn't have files, you would have changes, and any change could either be like a rename, a delete, it could be modified, and if it was modified, you would have like the actual hunk data there. So if you check type modified, you would also have the hunk data. So they would be like renames and deletions, and additions would kind of be the same kind of change item on the same level as the actual hunks. And this doesn't make sense either. So what I've been thinking about now is that these hashes are like IDs, right? So I've been thinking about rather changing this to an object, because you are literally making changes to files, and you can and what you can do then is like you can say package.json, for example, and then we made some changes to this package.json. So that change could be type, let's drop that, where the type could be modified, let's just call it M, and then you would have like hunk data for that. But what you would also do is yes. So the point is that this is an ordered list of changes. Let's put that in. Ordered list of changes. What I mean by that is that this array will always, regardless of what commit they're part of, like if you just like make the commits disappear, there is an order of changes, right? So maybe I modified a line on the first commit, and then I modified 2 other lines on the second commit. But if you think about the changes themselves, they have like an order. So this would be the same kind of order, where this is the latest change, and then I might have another type like this, which is also modification, but this could be part of a different commit. That's the point. So what I want to do is rather give this also a hash. So this would be part of hash 123, which is, or let's just call it commit 3, C3. And this will be part of hash C2, for example. So the point is that from this data structure, we can derive what commits are there. We can also, I think, because this is the tricky thing. The tricky thing here is there's an order of commits and there's an order of changes. And this is what I can't figure out. Like, what's the best data structure to... So this makes a shit ton of sense for the order of changes to a file. But then you have an order of commits. So for example here, it wouldn't make any sense to do this. But the data structure doesn't really reflect that, which annoys me. And I want to find a data structure that makes it easy to move these changes around between commits. So, I'm gonna have, now I'm getting into like thinking mode, so you'll have to excuse me, because this is where I'm having a hard time. Like, I need to wrap this data structure and this mental model in my head, or I won't be able to like efficiently code it. So if we think about the actual UI where, okay, we're displaying commit 3, we're displaying commit 2, there's a hunk in package.json on commit 3, there's a hunk in commit package.json on commit 2. And then I move this hunk to commit 2. And basically the only thing that needs to happen in that case is that I'm changing the hash to C2. That's the only thing that needs to happen. That's fine. Because there's two things that needs to happen. There's the change of the commit reference, and that's the thing I kind of realized when I went to bed last night. Moving hunks around is not about just moving the hunk. There's two things happening. There's a change to the commit reference, and there's a change to this array of changes, which is represented here. And I think this data structure more easily allows us to change it. But let's think about this. So what if I move this one to commit 3? So I will just change it to 3. That's fine, right? But now the challenge is, what if I took this thing and I changed it to C1? What needs to happen here is that I need to change okay, so what I think needs to happen here is, I need to make notes of this. So when moving hunk, we need to find the index. So when I say that I move this hunk, so literally in the UI, I move this item to commit 2. And what's going to happen under the hood is that it's going to see that there's a target commit of C2. And then what I'm going to do is I'm going to look in the array of package.json, and I'm going to find the first index of C2, find by index, or whatever it's called. And that's going to give me this one. And then I'm actually going to move this item in front of this index. The result of this is that the array doesn't change in this specific example, right? And what also happens now is that when I try to transpose this change, I'm going to talk more about that, nothing will happen because I'm moving from and to the same index. I'm moving hunk, find index of target commit to get from to index. Yes, this is it. This is it. So, but now if I wanted to move this to C1, right? The target commit is C1. Well, I can't find... Okay, we need two things. Let's see. We still need the array of commits. So we'll have a hash, let's call it C1, sorry, C3. We have a hash of C2, and we're gonna add a hash of C1. We still need the commits, right? But this is where we're gonna decouple them. So what's gonna happen here is that I'm gonna, in the UI, I'm gonna move this hunk from C3 to C1. And what's it gonna do is, again, try to find the index, but it returns -1, right? Because it can't find the index of where to move that change. So what we need to do then, if it's -1, is to find how do we know that it's going to be last? Like, I know it's last because it's like it's after C1, like visually here, but like in code, how would we identify that? Like, what if there's nothing here? Well, then I would just push it. Okay, I think well, the thing is, like, if I move, oh, god damn it. So if I move something to if I move this C3 to C1, god damn it, my brain is breaking. Okay, so the way I think we should do it is we can't just order it either. Okay, so what I was thinking is, what if we just change it? We change it to C1, and then when we yeah, maybe that's better. Yeah, okay, so I actually did something similar in the proof of concept. So what we're gonna do is just change the SHA. Then we're gonna sort, take note of, well, first take note of current index. Just change the SHA, sort, yeah, because the point is that whenever I change like a later change to a previous commit, I always want it to be at the top of that commit, right? Because it's a later change. And then we're going to talk about the opposite. But what we can do is sort by SHA. So what's going to happen here is that it's going to sort, C1 is in the wrong place, right? So it's going to bump it down until it actually meets a C1. Then it's going to stay in place. That means if there's already a C1 change there, it's going to stay at the top through sorting. And then we're going to do find new index of change. And then we have the from to, and we can transpose the changes, transpose and replace array. So that's how transposing works, is that it's going to take this whole array of changes, it's going to transpose it, and then it's going to return a new array. Oh fuck, but the transposing currently... Wait a minute, maybe it's better to... Because the transposer currently, like, if I know the before and after index, the transposer actually moves it in the correct place. But if I do the sorting approach, it's already been moved, right? So what is a different mechanism for me to figure out what is the new index without actually sorting? I guess I kind of have to just do it manually. Like, I can do a for loop. Like, I'm only changing one thing at a time. So I know this is the thing I want to change. So I can take its current index and then I can like... Ah, for fuck's sake. How would I do that? Like, I could find its new index by like just iterating the changes and then look at the hash. Like, okay, this is the like I look up C1. This is the index of C1. And then I check, okay, the next one is C2. Oh, I need to move on. The next index. And if I'm at the end or actually meet C1, then I have my index. Yeah, I think that's not sort by SHA. Just change the SHA. Just change the SHA and get commit index. So we're gonna grab the commit index, which is 2 in this case, and then iterate changes and find new index. Yeah, so we see this one, we take C2, we find the index for it. We find the index for it, and we see that, oh, C1 is more than C2, we need to move on to the next thing. Which is a little bit confusing here is that, yeah, that like the last thing has the highest index, but yeah, that's just how it is. But the thing now is like, what if I do the opposite? What if these are two C2 changes and for some reason I want this change to move to C3? Let's look at our logic. So we're gonna take note of current index, which is 1. We'll just change the SHA to C3, and then we're gonna iterate the changes again. And then we'll find C2, and then we see, yeah, this is confusing. Like, if you were to read this logic in the actual code, you would be very confused about what's going on. I wish there was a more like natural way to do this. Because what's it gonna see is that, oh, C3 has a lower index than C2, so it needs to come in here, which is at index 0 in this case. Yeah, but I think it makes sense. I'm just gonna comment it. We're just gonna identify at this current iteration item, should this change referencing this commit come in now because it's later in the commit phase, or is it earlier, which means it has a higher index? Very confusing. And then we have find new index of change. We can transpose it, which replaces the array, which is gonna actually move it, and do the transposition. And the transposition is looking at the hunk data, the lines of changes, and it's gonna actually fix what lines the change was made on, depending on how added and removed lines changes the line number of changes. And that's actually quite straightforward. The problem is overlapping lines. So I'm not, yeah, the thing is overlapping lines. So maybe, because we don't really have time to start coding anyways, so we're just gonna keep this. Let's actually put it into, we're gonna create a new file called git state ts. We're gonna build this up ourselves, and then we're gonna move some stuff into, I'm gonna have this, and yeah, we don't need that. Cool. What about overlapping changes? So let's imagine, okay, so we're gonna be, let's imagine we're happy with this. Oh, look at this bug, interesting. Oh, it's a bug. And then we have, let's just use, so old start is 3, new start is, so this is a later one, so old start could be, you know what, let's just do it very, very simply. So we're gonna do, this is gonna be a C1 change. So we're gonna say old start, it's a single line change, new start. So both of these are changing line 3, right? And both of them has a reference, like they have a diff text. So let's again simplify. Diff text, and diff text here is like, we move from bar, it was bar and we moved to foo. I'm gonna just simplify it. This is sudo. And here we moved from foo to bar, like something very simple. We started out with foo, we changed it to bar in this commit, and then we added another commit modifying it back to foo. Now, if I were to just move this line, like use the same logic, like the transposition would kind of work. Because there's no change to the lines here. It's like I didn't add any lines, I didn't remove any lines, so it's gonna be correct in that sense. But the diff text is wrong, because this hunk is still gonna have a patch that's gonna state that it changed from bar to foo. But at that point in the actual history of the file, it wasn't bar foo, it was foo bar, right? So what do we do about overlapping changes? Do we not allow to move that hunk? That's one way to think about it. So alternative 1, prevent moving overlapping, beyond moving past overlapping hunks. That's one way to do it, but that's too easy. What we could do as well is we could also prevent moving past overlapping hunks. What was I thinking about? Yeah, automatically move overlapping hunks. So that would mean if I were to try to move this to C1, for example, hash C1, this would also, oh yeah, I guess that's a bad example. Let's imagine this is C2 and this is C3. So if I were to try to move this to C1, it will actually bring this one along with it because it sees that it's an overlapping. So as it's like, I guess as it's transposing, it also it looks at what lines are you affecting here. And then as it's transposing down through the other changes, it's going to identify if there are other changes that that overlaps, and then it will transpose those first, and then keep the order. So what would the result of this would be? Both of these would be C1. And let's call it transpose, which would work. But is it obvious that it happens? That's the thing, and it's not very common, I think, to do things like this. Like you're making multiple changes to the same lines. Like the only thing I can imagine is like you're implementing a function and you have like a console log in it, and then you have another commit where you remove that console log. But again, you wouldn't move that change. So if C3 was the console log and C2 was the implementation of the function, you wouldn't move C3 down to C1. You would move it to C2, and that would just work. So yeah, and the third one, but that seems the most complicated, is like merge overlapping funks. But that's super tricky, because even though it's easy to merge like if I did this, not back, I would do this, and then I would and then I would like immediately as we start rebasing, I would find these two overlapping changes, right? Well, no, that's not correct. So you start rebasing, you see these as two different changes, but then I move this one to C2 and identify overlapping changes. One thing is like adjusting this one to like fit with the lines. That's pretty straightforward, but the diff text, that's the problem, because now like it's actually the correct text will be foo bass, right? So I don't think it makes sense to merge overlapping hunks at all. So I'm kind of in this camp of doing one because it's the simplest one. It's as simple as, okay, I'm grabbing this one, I want to make it C, I'm dropping it in C1, I'm going through this array, I have the line changes, I can just do one pass first, just figure out are there other changes through the indexes I'm going through, or the changes I'm going through, that has changes to the same lines. And if there is, I'm just gonna give an error warning in the VSCode extension saying that you're moving past overlapping lines. And try that first, and then what we could do as like a second step is like still have a warning, but you can click a button and then do you want to automatically transpose the overlapping hunks, so you kind of move them with the other one. One thing I'm very curious about though is what happened in. So what I don't like about this array is that I think it should be in a different order. the reason is that when we're gonna apply, well, that's the thing. It's like, if you look here, these commits are in, oh, let's move, oh, my commit. So let's see this. Oh yeah, that's broken. No, it's working. Okay, so these commits are like oldest commit, newest commit, right? But when we look at the file, we have, oh, let's refresh. So we have latest commit, oldest commit. But looking at this, we have the first file change and then the last file change. So this is like in opposite order, which I find to be a bit, yeah. So I think I've maybe reason about this the wrong way. Yeah, this should have been opposite. Ah, but this is so confusing. Okay, but let's update that. Let's change it. This should be C3, C2. Yeah, and this will be correct with the transposer as well, because the transposer expects you to have, yeah, but that's easy to change in the transposer, like how it considers the order. But yeah, sorry. So we should have done this. Like, it should reflect the actual commit. So you'll have the last change first, and then you have the first change last. God damn it. What were we talking about? I forgot. Oh, I completely lost what we were talking about. What were we talking about? Well, it was the overlapping thing. So yeah, it identifies overlaps. It will start with a warning, and then we can automatically, yeah, it was how the transposer handles that. So what we would do is, yeah, exactly. So if we were to automatically transpose overlapping hunks, we would like identify first which indexes are overlapping with the thing you're trying to move. And then we would transpose those first, like from index to index. And then, and then we would do the final thing. Maybe we should try to do that. Oh no, now I remember. It's if I were to move this change to C2. Now we suddenly have like 2 items. Yeah, so when we apply the patch, yeah, but this is fine. This is completely fine. I wonder what happens to the diff though. Well, like when we apply the patches, we're gonna apply this in reverse, right? But then the question is, what about when you actually click the thing here? This is also based on, what was it? What did I call it? Show file diff view. How did this work? apply patch. Oh, wait. Oh. Oh yeah, sorry. Original yeah, because we're actually applying. Oh yeah, but that's fine. Sorry, I forgot. So we're applying the. Yeah. So Git will handle this on its own because we're applying this patch, and sorry, VSCode will handle this. So that's how we do the diff as well. We're applying the patch, so this is fine. Yeah, and we'll also do that when we actually rebase. What we're going to do is we're actually going to put the branch in its original state, and then we're going to go through your rebase, and we're going to apply the commit and the patches one by one. We're actually not going to do an interactive rebase. This gives us so much more control. But okay. Cool. I think I'm happy with this. I have to get to actual work. But we're gonna do this, and we're gonna do. I haven't made up my mind about the automatic transposing of overlapping hunks. But the way we're gonna implement the Git state is so that we can actually test it. So we're gonna. Like I've been using an LLM a lot. I've been using Claude to build up the proof of concept, which has been like, I would never had time to explore and figure out the UX or anything if I didn't use that. But yeah, now it's time to properly implement it. So yeah, we'll figure out what we're gonna do with that part of it, but we're gonna start implementing the Git state with these two data structures. I'm going to write the logic for moving things around and extracting different representations of this for the actual VSCode extension. So this is like the backend or the state management of the extension. Cool. We'll see when I get time to stream. I can stream every morning, but yeah, this was nice. I've kind of felt a bit, I haven't streamed for a long time, and I wasn't sure if I would find it, like the last times I've streamed, it hasn't been fun. And I think it's been because I just been nervous about what I've been showing on the screen because of the announcement thing. Yeah. Anyways, thanks for tagging along, and I'll hit a new stream when we're gonna actually implement something, and maybe I'll get started. Like I haven't mentioned it, but I have a new office now in the basement. We built like a TV room and an office / bedroom in the basement, so I have much more room now. I can actually code while the kids are in like playing video games, and yeah, it feels like quite a relief actually. And also I have to do meetings in the evenings now because I'm in Norway and Together is in San Francisco. Not that I do a lot of meetings, but like a few ones, and then it's nice to be able to go down to the basement instead of doing a meeting while my 4-year-old tries to sleep behind me. I've never done that, but yeah. Anyways, bye for now.